Hello students! Welcome to Math&Magic. For today's video, we are going to solve problems involving systems of linear equations in two variables. Many of the problems that are encountered in real life involve linear equations. As an example, the jeepney transportation fare. Let's assume that the flat rate or the minimum fare is at 9 pesos for the first 4 kilometers and an additional of 1 peso and 50 centavos for each kilometer or a fraction of it traveled thereafter. This concept can be expressed algebraically as y equals 1.50x plus 9, where x is the additional kilometer traveled after the first 4 and y is the actual fare. So if let's say Emil will travel from Santa Rosa, Laguna to Cabuyao with distance of 10 kilometers, the equation will become y equals 1.50 times 6 plus 9. Here we will only add 6 since the condition tells that we will only charge 1 peso and 50 centavos for succeeding kilometers after the fourth. So 10 minus 4, the difference is only 6. Now performing the operation, 6 times 1 peso and 50 centavos, that is equal to 9. Then plus 9, that is equivalent to 18. Hence, Emil needs to pay 18 pesos. Now going to the topic, as discussed in previous videos, the skill in solving a system of linear equations into variables is helpful in many areas of study. This concept can solve number relation items, age problems, geometric relation items, motion problems, mixture, investment, and others. Also remember that there are different ways on how we could solve linear systems. This includes elimination, substitution, graphing, and Cramer's rule, or using discriminant. To start with, here is our first example. This one is a number relation item. The sum of the two numbers is 56. Their difference is 18. Find the numbers. Now for the solution, we need to make first our assumption. Here we will denote the smaller number by variable s and the larger number by variable L. Next, we will form our working equation. According to the first statement, the sum of the two numbers is 56. This can be expressed as L plus S equals 56. For the second statement, the difference is 18. It can be written algebraically as L minus S equals 18. Here we will now proceed to solving the values of the variables L and S. For this item, let's use elimination. Notice that when we add the two equations, variable s will be eliminated or cancelled out. Now adding L and L, the sum is equal to 2L. On the right side, 56 plus 18, the sum is equal to 74. Dividing both sides by 2, here L will be equal to 37. Now using the first equation, L plus S equals 56. To solve for the smaller number S, it will be 37 plus S equals 56. Transpose 37 to the right side, that will be negative 37. Getting the difference of 56 and 37, S is now equal to 19. Now to check whether the values 37 and 19 are correct, we will substitute this to the second equation, L minus S equals 18. That will be 37 minus 19. 37 minus 19 is equal to 18. Thus, the numbers are 37 and 19. For our second example, an age problem, mother is thrice as old as her son. 10 years from now, mother will be twice as old as her son. How old are they now? Just like in the first example, we need to make our assumption. Here we will let M be the present age of mother and S be the present age of her son. Next, we will construct equations. The first statement, mother is thrice as old as her son, can be symbolized as m equals 3s. This will be our equation number 1. For the second statement, in 10 years, meaning we will add 10 to both ages, mother will be 2 times as old as her son. When written in symbols, it will be m plus 10 equals 2 times the quantity s plus 10. Simplifying this equation, it will be m plus 10 equals 2s plus 20. Then transpose 10 to the right side. This will be m equals 2s plus 10. Hence, we have the system m equals 3s and m equals 2s plus 10. For this example, let's use substitution. Here we will substitute the value of m in equation 1 to that of equation 2. This will be 3s equals 2s plus 10. Now transpose 2s to the left side, it will be negative 2s. Difference of 3s and 2s is simply s. Thus, the value of s is 10. Solving for m, let's use equation number 1. That is m equals 3 times 10 or simply 30. Therefore, at present, the son is 10 years old while mother is 30 years old. For our third example, a geometric relation problem, the length of a rectangle is 15 centimeters longer than its width. When its width is increased by 3 centimeters and its length is decreased by 5 centimeters, the area of the new rectangle is 20 centimeters squared bigger than the original rectangle. Find the dimensions of the original rectangle. For problems like this, it's better to have an illustration. Here we have the original rectangle where L is the length and W is the width. Meanwhile, as stated in the problem, if we will adjust its dimensions such that the original length will decrease by 5 centimeters and the width is increased by 3 centimeters, the new rectangle would be like this. Next, we will now form our working equations. In the first statement, the length of a rectangle is 15 centimeters longer than the width. When expressed in symbols, it would be L equals W plus 15. For the second statement, when its width is increased by 3 centimeters, that will be W plus 3, and the length is decreased by 5 centimeters, which is L minus 5, the area of the new is 20 centimeters squared larger than the original. In symbols, that will be quantity L minus 5 times quantity W plus 3 equals LW plus 20. When simplified, the product on the left side will be LW plus 3L minus 5W minus 15. Here you may use FOIL method. Then equals LW plus 20. Combining like terms, the equation will become 3L minus 5W equals 35. Using substitution to solve for the values of length and width, it will be 3 times quantity W plus 15 minus 5W equals 35. Solving the equation, left side will be 3W plus 45 minus 5W, then equals 35. Combining 3W minus 5W, the difference is negative 2W. 45 when transposed to the right side, it will be 35 minus 45 or negative 10. Dividing both sides by negative 2, W is equal to positive 5. Now substitute this value on the first equation. L will be equal to 5 plus 15 or 20. Hence, the dimensions of the original rectangle are 20 centimeters and 5 centimeters. Now, the other examples of solving systems of linear equations into variables as applied in motions, mixtures, and investments, that will be discussed in the second part of this topic. Thank you for watching. God bless.